Welcome everyone to this webinar, Deep Dive on Multi-Region Architectures with Amazon DynamoDB. I'm your host, Robert McCauley. I'm a DynamoDB Specialist Solutions Architect. I help customers with NoSQL and DynamoDB. I joined the company years ago as a relational developer, so I appreciate the change in thinking that's required for moving to DynamoDB. The other title for this is all about DynamoDB Global Tables. All right, to get the most out of this talk, you should have a little bit of familiarity with DynamoDB itself, what it is. It's a fast and flexible NoSQL database for any scale. We use this internally for virtually all of our projects. We've moved off relational commercial databases into largely cloud databases in DynamoDB. So we use it to power the Amazon website, the AWS console and most of its services, Alexa, fulfillment centers, everything. The idea here is instead of a server that you'd run or an instance, you just have a data API and you do reads and writes to that API as a developer. There's no server to manage. And we've been adding features to DynamoDB over the years. It's very enterprise ready. We have a lot of security features, backup features, export as well. So to think about multi-region applications, let's think about what types of characteristics they would need to have these days. If you're going to launch some sort of a new media or social app or a game or something, you might not know how many users you're going to have in your system. Could easily be popular and scale up to millions of users. And you probably want to go worldwide, go global, so that you can reach users in all regions and all continents. And those users are going to want to have very good performance, meaning low latency, as they do interact with your service. We don't want the database to be a bottleneck in any way. The scale, we'd like to be able to have elastic scale up and scale down. It's really hard to add capacity when you're running a fixed size, big database server. And availability, we'd love to have 100% availability, but even if we got 5 nines of availability, that would be less than 5 minutes downtime a year. I think that would be a great goal for us, but we definitely don't want to have, weekly maintenance windows where we have to take the whole thing down just because the database needs some sort of patching or upgrading. So with DynamoDB, we have a number of strategies that we'll walk through today, talking about how you can achieve some of these goals with different architectures and topologies. And the first one is a single DynamoDB table. And this is what you start with when you create a DynamoDB table. You have to go onto the console, pick a region to be in. Maybe it's EU or region, for example, and then you go ahead and create the table. Once you've done that, you already have a pretty darn good solution. With a single region, you have a very high durability because we always store your data across 3 availability zones in a region. The availability, because of that, is 94 nines, 99.99, or about an hour downtime per year. It's already globally accessible, so you have these global endpoints which your application code can reach from anywhere in the world, and it can certainly scale to any level. We see DynamoDB tables sometimes that have trillions of records and can scale into tens of millions of reads and writes requests per second, for example, on our own Prime days. Problems, however, is it's a single point of access. So if you're in that region, great, but if you're further away, then you're going to have higher and higher latency because of the speed of light, for one thing. There's also a slight risk of a regional outage or isolation. It's pretty rare that regions, blow up and disappear. What does happen occasionally is the network itself has problems, and that region may be cut off from other regions and may appear to be down. And at that point, it's as good as down because your end users can't access it. And in many industries, your company may be operating in an industry where your regulators or your auditors or governance requires you to have a multi-region solution anyway. So can we get away with a single table and maybe do backups? We certainly can do backups and cross-region restores now with DynamoDB. We can even export to our own S3 bucket. And this might help in a happy situation where we want to move the data for some reason to a new region. We can do that. But in the case of a region outage or a region isolation, it's not going to help us. If that region is offline, then it's too late to do any cross-region restores and try to move the data out of that region. And even if you could, it could take hours for the data to move and to be restored. At which point this region might be coming back online anyway. So Before DynamoDB Global Tables came out, people thought of how could they do their own replication. With DynamoDB, we have this thing called the DynamoDB streams, and this is a change log of all the modifications that your developers are doing to your table. So you can hook into the streams, and every change, every data event that happens will be reflected in the stream, and then from there you can write code to access the stream and do something with those changed records. And most commonly, you'd hook it up to an AWS Lambda trigger, and from there you could send it to other services like Amazon Elasticsearch for a full-blown search engine. You could send it to SQS or SNS maybe to be notified if the temperature or pressure in your factory goes above a certain threshold. You could have near instant notifications. But to accomplish replication, customers would build up quite a convoluted system, maybe send it to Kinesis Data Firehose, land it in S3, write some sort of a program to copy it and apply it to another region. Maybe use EMR, Elastic MapReduce even. And this is all to replicate one way. You'd also have to do the same in reverse to active-active replication. So it'll get to be really difficult. Enter DynamoDB Global Tables. Well, let's talk about what global tables are. We essentially do this replication for you. So you can have 2 or more tables participating in a replication group, and each table is available for reads and writes. There's no concept of primary or secondary. It's fully automatic. So once you set up global tables, you simply can define a replica, as we'll see later on, and we'll move the data into the new copy of your table in a different region if it's necessary. But you don't have to create any network links at all. There's no VPC or routing or internet gateways or anything like that involved. You simply just logically create a replica and we take care of the rest, which is really nice, I think, for administrators. And you can set up a global table. If your table is empty, it would take you about 5 minutes to set this up. And now you have a fully replicated solution up and running, and you can write to either side. Once you have it going, you get an extra 9 of availability. So 5 nines of availability instead of 4. The goal of global tables is to converge the system to an identical, consistent state. So to make sure that each replica table that's participating very quickly resolves to the identical images of all the items and the same counts of items on all sides. Much more on that in a moment. This is a deep dive after all. So let's think about the latencies and the speeds and the consistency that you get when you use global tables. Once you set up a global table, you can see here the application on the top and then the DynamoDB tables are on the bottom. The tables themselves still look and feel like normal, regular DynamoDB tables to your users and developers. And when I say that, I mean your reads and writes. Your writes are always going to be essentially to a local copy of your table. You're going to point to a certain region table. And you're going to get synchronous success back from that. So if you do a put item, you're going to get HTTP 200 success, usually within 5 to 10 milliseconds. So very, very fast performance. And then once that's finished, then the shipping across the miles happens. So our replicator service is going to find that data on the stream after, maybe 10 or 20 milliseconds later. It's going to start to package it up and move it across to the other replica tables and apply those. And then that incurs quite a lot of latency. So it's important to understand that the client sees a success even before the replication has completed. So here's a look at some latency comparisons that I ran yesterday just to prepare for this. So just to put item latency to a table locally, you can see this yourself in your CloudWatch dashboard. But it can be very, very fast. 5 milliseconds. Here we see even under 4 milliseconds. Replication latency is usually about half a second to 1.5 seconds on average, right? And here's some stats I pulled. I had a table in US East 1, and I replicated it to US East 2 from Virginia to Ohio, and also from Virginia to Ireland in EU West 1. And I saw these latencies here. They're still under 1 full second, but they're, I'd say, about 200 times slower, approximately, than the regular consistent writes to DynamoDB. Now, you can add replicas to You can have a two-way replication, a three-way replication. You can do as many as you like with DynamoDB. So it's up to you. The storage and the write costs are going to grow with each replica that you add. So it's going to get more and more expensive the longer you do this. But we definitely see customers who are having three-way replication, even 4 units of replication. And there's reasons for doing that, as we'll see in a moment. We have at least 21 regions available. The number is always growing to choose from to set up these different replications globally. And if you're in China, we even have a special Chinese network with 2 different nodes in it. So you can replicate within that country and still take advantage of global tables. Now, let's dive deep. Let's talk about, the consistency and something called Brewer's CAP theorem, CAP. And I love this when I first heard about it. It really clarifies a lot of the thorny problems of distributed computing. So what Brewer said is you can pick any 2 out of the list of 3 here. Consistency of your data across all nodes, availability, is the system up or down, and partition tolerance. That word partition comes up a lot, but here we're going to mean like a cut in the network, meaning if these 2 replicas get isolated or cut from each other, maybe a backhoe ran over the fiber cable, for example. So we can pick any 2. And you can see there that there's a cut happening. Now they're split. And in this case, what we do with DynamoDB global tables is we prioritize the availability and the partition tolerance, AP. And we don't worry so much about consistency. We want these global tables to be up and running all the time. We know that networks fail. Not just networks fail, but networks get degraded sometimes. Sometimes it's not a failure, but maybe the network just slows down to half its normal rate, and the replication is struggling to succeed. That's also a problem. But in any case, the 2 replica tables are going to keep on humming along, accepting read and write requests. And if that happens long enough, then you can imagine changes are going to be queuing up on each side, trying to get across and replicate to each other. And there's a good chance the tables may diverge. So if you're writing to the same item on different sides, those might have different values depending on how your application is using the item. But that's a risk we take. If you, for example, wanted to change how this approach works, maybe you want to really prioritize consistency in the case of a partition tolerance. Well, we can do that simply within our application code. So if we do a CP system, we have available to us a stat in CloudWatch called replication latency. And you saw it on the other slide there. It's typically about half a second to a second to maybe a little more. But keep an eye on that. If you see that number, if a network gets cut and the replication is starting to fail, there's our partition again in the middle, what you'll see is the replication latency go very, very high. It might go to 2 seconds, 3 seconds, 4 seconds, as no traffic gets across. What I've been told by the product team is eventually, if that lasts long enough, for a very long time, it might actually also go straight to 0. And that's a big red flag. That's essentially saying replication has given up, it cannot succeed at all. So that's just as bad as, replication going to infinity. If in any case, if it goes too high, above some threshold that you're comfortable with, or that you're used to from, running global tables for a little while and watching it, or if it goes to 0, you can assume that there's been a partition. You can assume that your consistency is perhaps at risk if you're allowing writes to both tables. So what you could do then there is simply your application could halt operation and say, hey, we don't want, we like consistency. We need consistency. We're going to go ahead and take away availability. So on that condition, the application could say, I'm going to just stop reading and writing altogether until I see those replication latency numbers come back down to normal. And then I can assume that the system is consistent. Otherwise, we're going to close shop and not allow any reads and writes. So this is something you can do outside of DynamoDB global tables to implement your own, 2 from the CAP theorem. Now, let's talk about conflicts. There is a possibility in that 1 second or so, if you had simultaneous or near simultaneous writes to the same item, what would happen is there'd be a conflict. So those would meet across the wire, like letters traversing in the post. And once the system realizes that, there's a conflict, there's 2 different updates to the same item, that crossed on the wire, we're going to go ahead and compare them into a conflict resolution. And it's very, very simple, the approach we take. We simply look at the timestamps of both of those, and we take the later one. So the last writer wins. Whoever was earlier, unfortunately, going to lose that conflict. And whatever update they were trying to do is going to be rolled back on their system and ignored on the source, on the final system. It then ensures that all replicas will converge to a consistent state. It also introduces some very quirky side effects on this edge case, right? Because if you try to do a delete of an item and then, a millisecond later on the other side, you try to do an update of the item, the update is going to win that conflict. And the delete is going to be resurrected and brought back. So even though it was temporarily gone from your table, it could come back with the new updated item from the last writer wins scenario. All right. So let's look at some more strategies now. Now that we have global tables available to us, how would we set up our replicas to maybe to avoid this kind of conflict altogether? I think we can do it. So by default, it's active-active, right? We talked about that. You can certainly write to any global table, and they're all relatively equal. But we could certainly designate maybe one region is the one that we're going to allow our application to write to, and treat that as the only write target, but then read from either side. So here's how that might look like. Essentially, write to a primary and read from any other copies. So we can almost think of this like read replicas like we see with other systems like RDS and Aurora. We don't call them read replicas, but you can treat it like this with this kind of pattern. So will this work? Well, there certainly wouldn't be any write conflicts because we're only writing to one table. We do have replicas closer to our users in different continents, so that's good for reading at least. But the write latency still may be very high. All the writes do have to get funneled to a single region, which could be a long distance. And there is, of course, the risk of if that region itself goes offline, then nobody can write. So let's try a different strategy. What if we write according to the nearest region of the users? Can we do that? Well, I think so. Our users are probably going to be web users or mobile users, and they probably don't talk to DynamoDB directly. You probably talk to an application running on EC2 or Lambda or a server on premises or something like that. And we, as those application platforms have their, get into the AWS cloud, they have their own region. So based on that region that they're running in, we could go to a global table replica that's in a matching region. Or we could go to a nearer region if we have, accepting users from all around the world. Maybe we want to take users from India, for example, and route them to Europe just as some sort of simple logic rule. But we can certainly have application logic to route it to the nearest region or the same region. Now, you can also set up Route 53 DNS or a global accelerator. These two services can help users coming in from anywhere on the network to be routed to their nearest region. Right, Route 53 DNS has all kinds of weighted algorithms to route to whichever of your application endpoints is less busy or nearest or different rules that you might set up. And Global Accelerator gives you kind of a global IP address that looks the same all around the world, but when you start to use it, it detects through the edge where you're at, and it's going to route to the nearest region there. So you can do that on the application side, and then simply pick a replica that's appropriate for you. Now, let's talk about another strategy. Maybe we want to keep a hot standby for what we call region evacuations. And what this might mean is if you have a 3 or 4 replica environment with DynamoDB, maybe you're using these two that we see here. Maybe you're using US West and EU Central, for example, for all your application traffic. But you want to take down US West for maintenance. Maybe the whole stack itself needs to be refreshed or updated, or we just want to take it down or simulate a failure even. We can set up a hot standby. We can simply ask DynamoDB to create a new replica for us in US East 1, you can see here in the center. And now that's available. Now we could take the entire stack down and route traffic from either side to this new replica. So it's really a nice tool for flexibility for us as we manage our global infrastructure. Another strategy is if you're ambitious and you want to expand your application worldwide, then we can use DynamoDB to very easily and quickly do this. So we can set up a replica table in any other region. We can ask DynamoDB to populate that, and it'll go ahead and take whatever's in your existing replica and move it across and set up that table for you. And once that's done, you'll be at least that much further along to launching in that new region. The table and the data will be there so that those users will have low latency on day one, launch day, critical day, for attracting and maintaining users. So what will happen internally is when you add a replica to a table, that's all you have to do. You say, hey, existing table, boom, add a new replica somewhere else. You wait and it happens. If the table is empty, like I said, that could be just a couple of minutes. But if the table is a significant amount of data, then what we're going to do is do this process. Imagine trying to do this yourself. We're going to be taking a backup of your table using our traditional backup, infrastructure that we have for on-demand backup. And then we're going to restore that and ship that across the network to where it wants to be, and then restore that into a brand new replica table. And all the while we're doing that, we're going to be monitoring the original table. We know that doesn't stay still. So we're going to be also watching that and looking for changes as of the point in time that the backup happened, maybe even earlier than that, just to be sure. And we're going to watch and then apply all those changes and ship those across as well until both the backup and restore is complete and all the changes and deltas are also complete. Then you'll see that the replica region is back online and status is active, meaning it's fully synchronized and it's participating in the global table. And all tables will be identical or near identical as replication happens. So let's talk about some enhancements. They keep adding features to global tables, which we love. There is a little quirk with global tables. We did have a versioning issue a couple of years ago. We started off with what we call global tables version 2017. Now we hate to do this within AWS. We're serverless. We have APIs. We don't try to version anything. We don't think about database, maintenance in terms of applying a new version or patching it. But then we did change a slight bit of the functionality. We improved global tables, the 2017 version that we had. We came out with the 2019 version. So you'll still see this in the documentation as you try to choose which version. We'll, of course, choose a later version going forward for all new customers. If you happen to be on global tables version 2017 still, we encourage you to upgrade. You can find a process in the docs for upgrading, and we've had customers go through it and with great success. Now, with the newer feature that we talked about was the ability to take a table that's not empty and add a replica to it. We just described that. Also, going from 2017 to the newest version of global tables, the write capacity consumption, meaning the cost to you or the customer, was greatly reduced. So it's much more efficient. There's less writes that you'll be paying for as a customer. More in cost in a moment. Some more enterprise features that came out recently for global tables, and you might be interested in this if you're a bank or a finance company or a brokerage. Now we can have customer managed keys supported within global tables. We've always had this for a single region DynamoDB table. In fact, DynamoDB tables are always encrypted at rest with either our key by default, which is free, or you can provide your own key and have us manage that, or you can just provide your own key and you manage it yourself and provide it to unlock your data. Those three have been supported for a single table, and now they also work with global tables. So it's a great win for customers that need that feature. Data is always encrypted in transit as well as at rest. And in transit, it's really just the AWS cloud itself requires TLS for inter-service communication and communication from the end user to AWS. The AWS SDK typically handles this for you, but that's also encrypted in transit. Now, we're going to talk about the good, the bad, and the ugly. So here's one thing that we do not support, and that's DynamoDB Transactions. We get this request a lot. Wouldn't it be nice if we could somehow have, DynamoDB Transactions, which are like traditional database ACID transactions, ledger updates on multiple slides, would it all succeed or all fail atomically? We don't support this. We saw in the very first slide how writes happen locally and then they eventually get moved to the other side. So we do have eventual consistency. We have eventual consistency on the global tables, as you'll see. And the reason for that is it's really complex and slow and not as reliable to try to do anything across global networks. We saw it's about 200 times slower for the latency. The CAP theorem comes into play. This really fascinating two generals problem that I learned about in college comes in as well, which you can read there. You can find that on Wikipedia. But it basically says, if the network is at all unreliable or suspect, it's really hard to coordinate something like a transaction across multiple items, across multiple regions, and make sure that they both all succeed or all get rolled back. You can end up with a race condition where you're never sure if the other party, got it. And, you keep sending confirmations back and forth, forever and ever. So because of those kind of philosophical reasons and architectural reasons, we do not have DynamoDB transactions with global tables. I have not heard of any plans to introduce them. I think there's some, the reasons we just talked about there. So we wanted to think about DynamoDB transactions in the scope of a single region, a local table. We still have the very high durability. We have 3 availability zones. And we can do traditional transactions within a single region. When you create replica tables, another caveat is we want those tables to be identical, twins of each other. If you do this yourself, you can certainly create the second table. Manually, it's much easier, I think, to just say add a replica to an existing table, and that'll take care of everything for you. You'll create a table in the new region with the same name, the same capacity settings, the same global secondary indexes, if you have any, the same schema, partition key, and sort key. So, and that's a great way to go. I would leave them the same, especially for the write capacity. Very important that the write capacity be identical on both sides. In fact, we want to make sure that the second side of a replication doesn't become a bottleneck. So if you're doing, 100 writes per second to table A, you can imagine that we're going to be trying to do 100 writes a second on table B because we're shipping all those changes over and applying them. Right? And likewise, if you have 50 writes on table B a second, you're going to also need 50 writes on table A. So in aggregate, maybe 150 writes per second for both sides of both tables to support that level of traffic. So keep the write capacity the same. In fact, I think we require the provision capacity to use auto scaling to make sure that the write capacity goes up and down roughly at the same time on both sides. Or you can use on demand as well. And that's, much more aggressive for scaling up. Hard to overwhelm it. What you can do, however, the read traffic could differ. You can imagine you might have your original application in your beginning region and it's really popular. You have millions of users. You launch in a new region and now you only have thousands of users. So they don't read as much as the first table did. So you can go ahead and set up a custom auto scaling policy within the app auto scaling construct and put a different auto scaling policy onto the read side of a region 2 table, for example, to optimize your spend. All right, speaking of spend, let's go ahead and talk about pricing for DynamoDB global tables. If you have a single table, before you go global, we measure the write capacity and read capacity in these things called capacity units. Write capacity units would be a WCU. And you can see the cost of those. It's either with provision capacity, a level set that you have over time, the level of capacity you need, or on demand, we just simply charge you according to how many you consume in a very serverless way. With global tables, that goes out the window. We now have a new unit called RWCU, or replicated writes. And that's also at a premium price. In US East, currently it's about 1.5x the cost of a normal WCU. And that includes the transport. So we have to write it locally, of course. We also have to move it across the network and pay for that network. So you'll see the premium markup on the RWCU to support that. And then the other replica side, the target, is also going to need its own right. So that also consumes the equal amount of RWCU to apply all the changes. So you can estimate your cost there by assuming you need to have 2x the writes for a two-way replication at those RWCU rates. And then the storage is build the same rate, but you're going to have 2 tables instead of 1 table, so you'll expect 2 times the storage cost in that case at the nominal gigabyte per month rates that you can find online. So does that seem expensive? Maybe, maybe not. Compare it to what you might be currently doing. If you have a relational database and you need to buy some very expensive vendor package to accomplish global replication. If you need to hire, administrator to keep an eye on this thing and to have a pager 24/7 and to be paged on weekends and get overtime pay, right? And you also need to hire a wide area networking expert to set up all the WAN links and, grow and shrink those as your capacity changes. When you consider the whole big picture, it might not be that expensive, especially with the simplicity of going to global tables, with a 5-minute setup. So it does cost more, but I think it's well worth it. Now let's look at a popular customer that's using global tables today. You may have seen their talk at reInvent this past fall. We had a pleasure of talking to Attilio Giue, who talked about how Disney Plus is using global tables in different use cases to support the very popular Disney Plus streaming platform. So one of the use cases is this Booksmart service. You're watching a show. I didn't realize this until I saw his talk, but the system is recording bookmarks all the time as you're watching it. It's not just when you turn your TV off, but you're maybe every minute or every few minutes, it's going to record a bookmark to say, hey, the user got this far in the Mandalorian show, right? If your TV turns itself off because you fell asleep, then that's the latest bookmark essentially, and that's where it would pick up. So the bookmark service is billions of these per day that are getting generated by all the users watching the Disney Plus content. And what they do is they use a telemetry service, simply a sophisticated way to route the traffic according to where the user is on the internet and route it to a nearby region. Then they send that data into Amazon Kinesis data streams and to a Lambda function called the bookmark writer. And then that lands into a DynamoDB global table. And they really like this approach because the global table simply is a key value lookup, for this customer, for this series they're on, store, what episode they were at, or how many minutes they got through. And that's it. When the user comes back tomorrow to finish watching, we simply do a get of that same item. We find out where they're at. Now we can queue up the video stream to that exact point. The user's off and running and continuing to watch the show. So that's one use of global tables. Also, the watch list in Disney Plus. If you go in there and you want to add some of your favorite shows to watch later, or you want to finish watching a show and take it off of your watch list, that watch list itself is run by a DynamoDB global table. And this is even simpler. And this is the simplicity of serverless in general. Look at this architecture. So we simply have they have a content API. It's backed by a DynamoDB global table called Watchlist, and they simply add items that they want to include in that list, or remove items, or pick an item. The recommendation service within Disney Plus, the recommendations themselves are handled not by DynamoDB, right? It's not usually a machine learning solution or an AI or anything like that. But once all those recommendations have been generated by another system, the final results for you, tailored and personalized to you, are stored in a DynamoDB global table. And the team did this for an interesting reason. They did a lot of work to do the machine learning, recommending recommendations for users. They know users could be around the world. You could imagine traveling, or even having family members on the same account in different regions. So they didn't really want to worry about how do we fan this out and put the final recommendation near the user. So they just dump it into a global table, and global table essentially finds the user or makes it so globally available that wherever the user is, they can get it quickly and easily. And there's even other use cases. So I encourage you to check out the talk, or if you think about that tonight if you're watching Disney Plus. All right, now let's take a break. Let's do a demo of global tables setup and monitoring.
Okay, let's start the demo. We're going to be creating a global table with 2 replicas and 1 primary table. And to do this, we can simply go to the global tables page on the website and find this tutorial, creating a global table. And we can do this through the console. I'm going to use the AWS CLI, the command line interface. But you can see the steps are pretty straightforward. We simply create a regular table called music with a primary key. Once that's created, we're going to enable streams. And then once that's finished, we'll just simply add a region to the table. That'll tell the system to go ahead and create a replica and set up the global tables links between those 2 tables. an active, and then we can repeat that for other regions as well. So here's the command line interface that we can use to get started. Let's start in US East 2, which is the Ohio region. I'm going to paste that in here and create this table. And to check on the status of the table, we can run the AWS DynamoDB describe table command. By the way, did you see the specification here? I enabled streams right when I created the table, so it's on. It's recording the new and the old images. So describing this table, it says table status active, so it's already created and ready to go. Great. Now let's follow the next step in the tutorial. Let's create a replica. And if your table is empty, this is going to be very quick. Update table, table name music, replica updates, create a new region for the same table, essentially created a replica in US East 1, which is the Northern Virginia region. So I didn't even have to create the table directly. I just asked for a replica to be made, and it'll create an identical table with the same name, the same settings, which is exactly what we want. It's very important to have the write settings identical, because a write to any replica in a global table will cause writes to occur to all replicas. So we want to be able to have the same capacity to handle writes across the whole system. So now let's check the status of the original table. Describe table, it's active. Oh look, so now we have this new section called replicas, US East 1, and that's also active. Fantastic. And let's repeat that one more time and put another copy in EU West 1, the Ireland region. Region EU West 1. Okay. Now let's do the describe table command again. It looks like it's still creating that one because it doesn't show the replica in EU West 1 yet. So we'll give that a moment to complete. In fact, I have a shorthand command for this. We can use this command line interface query operation. It's not to be confused with a DynamoDB query, but this will format this big set of results into what we're looking for, just the replicas. We'll give that a moment to complete as well. Let's check the table status. Looks like it's active, the original table. Let's check the replicas. Aha, there we see both are there, including the new Ireland region. Looks like our global table is set up and ready to go. So the next step is to go ahead and put some items into this table. And we can do this with some of the put item commands that you can see here. So we'll put in song item 1, song 1 into the original table. And let's do the rest as well. So I'm going to put in 3 different items. Okay, now with that, the table has been set up. Let's check to see if the data got replicated to the other regions. Let's go ahead and change our region to Ireland. And there's our replica table there. And the items, there's the items that we put in there. So great, looks like the replications worked. Now we may be wondering, how fast did that happen? What's the replication latency? And we can go into CloudWatch and request that metric and keep an eye on it. So to do that, we simply come into CloudWatch console here. And I'm going to go back into the Ohio region where the original table was and measure from that perspective. Now I'm going to click on the metrics section from the left nav here, and you can see there's lots of metrics to choose from, but I can use a search box and type in replication latency. And there we have it. It tracks across all the replicas, so I'm going to request all of those. I'm going to go ahead and put it into a number. And there we can see the latency. It's pretty good today. 424 milliseconds to propagate to Ireland and 302 on average to propagate between Ohio and Virginia. So that wraps up the demo. Hopefully you can use these CloudWatch metrics to keep track of how your global tables replicas are performing.
All right, so today we learned all about multi-region architectures with Amazon DynamoDB, how we can set up global table replicas to put our data near end users for lower latency and to have more copies of our data for increased peace of mind. Hope you enjoyed the talk. Please check out our Twitter feed at dynamodb.com. There's lots of great content on there all the time. You can check out my own Twitter feed at Rob McCauley as well. Thanks, and look forward to talking to you. We're going to have some questions and answers now. So go ahead and ask your questions live. We'll do our best to answer them. Thank you.